Hello everybody, I'm Dan. In this tutorial I'm going to introduce you to bits and bytes. Let's go and open up our web browser to my website, thegpu.com, and we'll scroll down here to See Tutorials. And we'll select bits and bytes. So in this tutorial I'm going to discuss the fundamentals of how bits are used to create all types of data. Now memory management is the single most important topic when it comes to successful C programming. You will need a solid understanding of how your program's memory is structured at the lowest level so you can manage it effectively. Now, unlike many higher level languages, you are in charge of ensuring that the values that bytes represent remain in their allocated space. Now, this tutorial is mostly conceptual, and the source code that I will be demonstrating is well beyond the scope of the tutorial series thus far. So let's talk about bits and byte. Now, your hard drive, thumb drive, SD card are all examples of disk memory storage devices. Typically, each one has a memory capacity listed in megabytes, gigabytes, or terabytes. Let's imagine that we have an empty thumb drive. If we could peel it open and look at the memory, we would see billions of zeros all lined up. Now, a bit is a single memory location that contains either a 1 or a 0, and there are 8 bits in a byte. Now, what would a single empty byte look like? Well, it would look like basically 8 number zeros, right? So let's talk a little bit about the binary numbering system, which happens to correspond to bytes and bits and everything like that. Now, the binary numbering system is typically read from right to left. The value in the rightmost column is referred to as the least significant bit, or LSB. LSB, lowercase, right? And that would be this bit right over here. Now, the value in the leftmost column is referred to as the most significant bit, or MSB in lowercase, right, which would be this bit right here. Now, don't worry about that terminology just yet. It will make sense as we go over some example code. Now, the rightmost column, 2 to the power of the rightmost column is 2 to the power of 0, then 2 to the 1, 2 to the 2, next 2 to the 3, power 3, and so on and so forth. Now, you may recall that any number raised to the power of 0 is 1. So this column over here has 1. If the column has a 1 in it, you simply add the max value of that column to any other columns that have a 1 in them. Here are the decimal numbers 0 through 15 in a binary chart. Okay? So this byte, and I'm only going up 2 to the power 6. The next one up will be 2 to the power 7, which would represent the byte. But for this particular chart there, I'm only doing the first 7 bits. So zeros all the way across is 0. Since we have a 1 over here, it's 2 to the power 1 plus all these zeros. And down here now we've got a 1 in the 2's column. So it's 2 plus every value that contains a 1, which is none. So this is 2. Here we have a 1 in the 1's column, a 1 in the 2's column. So we do 1 plus 2 equals 3. So 4 is over here in the 4's column. And so we have a simple 4, and then of course 5, we've got a 1 in the 1's column and a 4 in the 4's column, and so on and so forth. You get the idea on that. So it's basically the way the binary numbering system works. Is this topic too advanced? Yes and no. This topic is one of those chicken versus egg scenarios. In order to demonstrate the concepts in this tutorial, I would need to use code that is far more advanced than where we are in this tutorial series thus far. In my example code below, I use a function called printBits that I got from Stack Overflow. I made one small modification to it in order to separate individual bytes for better readability. Now this function will display values of the individual bits to the console. Let's go ahead and get into writing some code here. So let's move this off screen here. I've got a shortcut to the command prompt on my desktop. If you don't, you can create one really fast by right-clicking, selecting New Shortcut. CMD next, and finish. Okay, first thing you want to do is type in GCC. You should get this. Fatal error, no input files, compilation terminated. However, if you get it's unrecognized command, then you're going to want to go back and watch my installing GCC tutorial there, and probably just catch up on the rest of everything else for that matter. Let's clear our screen, cd / make directory here called demo. I already have that folder, but if you don't, it'll go ahead and create it for you. We're going to change directory here, create another folder called bits, change to that folder. And I'm going to use Notepad++ in this tutorial, bits.c. You, of course, can use Notepad. It comes with it. I just installed Notepad++. I would highly recommend it. It's kind of you know, it's one step above the notepad there. It'll do a little bit of formatting for you. Just make your life a little easier. Excuse me. All right, let's bring the browser back over here, and let's copy and paste all this source code here. Save that. Okay, so this is what's called a function here, print bits, and all this stuff is well beyond the scope of where we're at right now. I'm sure, of course, you recognize the int main here, and we are setting this variable I of int data type equal to 1, and then we're doing what's called executing this function here. And I haven't gone over size of or address of yet, but basically we'll go ahead and compile this, run this to the screen. You'll see how it works, and we're not really too concerned about the source code down here. It's all way beyond the scope of where we're at, but you just need to see the concept of these bytes here. So let's clear our screen. GCC, and our output file will be bits, and let's go ahead and run bits. And so basically what we've got here is we got this int value I setting equal to 1. So you can see in the least significant bit right here is 1. It's in the farmost right column, which is the ones column there. Now here's 8 bits, which is a byte, right? And there's 4 of them. 8 times 4, of course, is 32. So this is a 32-bit value. And in my particular system, in my compiler too as well, the int data type is a 32-bit value. So that's the maximum value that can hold. You can see that I changed the I to 2 and the I to 3, and then just keep executing that same function. So represented in binary there, this bit contains 1 in the 2's column. And for 3, it contains 1 in the 2's column and 1 in the 1's column. All right, let's go ahead and delete this. And let's come down here. And my dog something's got her all Twitter-pated there. All right, so this is what's called a for statement or for loop here. And I haven't gone over this yet as well. But basically what it's going to do is it's going to loop through 16 times, starting off at 0. And going all the way at less than or equal to 15, and this basically increases the value of x, and then we keep executing this here by passing in the x there, and I'll show you what that does here. I'll of course go over that sort of stuff in a future tutorial there. I'm going to clear the screen, and then we'll just run bits. And so these are the binary values of 0 to 15, and how that's all represented there, right? So for example, this is the 2's column, the 4's column, the 8's column here, right? So of course 8 plus 4 plus 2 plus 3 is 15, right? So that's how that works there. The next thing that I'm going to demonstrate here is basically I'm going to be shifting a bit to create a larger number here. And in this for loop, I start off with the number 1. And I'm going all the way up to 256, and basically I'm taking the value of x and I'm multiplying it. This syntax right here, I haven't gone over that yet, but this basically says we're going to be taking the value of x and multiplying it by 2 on each iteration through this for loop here. Okay, and so let's just go ahead and clear our screen, recompile, and let's run this here, right? So you can see the 1 value keeps shifting over and over and over again, right? So this is 1, this is 2, 4, 8, 16, 32, 64, 128, and 256, right? So that kind of gives you a good idea on how this works, you know, and if we wanted to go with 512, 1024, 2048, 4096, so on and so forth there. Just basically these ones would go right over there and keep shifting over. And then of course you would add the value of everything to the right of that too as well. So I'm just going to go ahead and minimize that, and leave you guys with some final thoughts here. Now don't worry if this tutorial did not make much sense. It really doesn't need to at this point. Obviously the source code was well beyond where we are in the tutorial series thus far. but I felt that it was important to introduce the concept of bits and bytes to make it easier to understand other concepts that I will be introducing shortly. That concludes this tutorial. Thanks for watching.